We have now made it to block 4 in topic 8, equations and inequalities, on page 243. So today's lesson is seeing math in all sorts of different ways. Is it okay that some people see it one way and some people see it another? Yes. Okay, it's kind of like when you're talking to a friend and a friend says, I think this person's cute. And you say, I don't think that person's cute. Is it okay that they think that person's cute and you don't?
Yes, ma'am.
Yes, it is. Okay? So, we all have different opinions in how we come up with answers. And that's what we're looking at, is everybody's answers. Do we have to like the way other people do it? No. But it's okay that they do it a different way than us. So we're looking at a new alien family today, the Ultimate Invader family. And here are their first 3 members of the Ultimate Invader family. What do you see? Let's go with, what do you see the same throughout their family? Yes, ma'am. The bodies, and what do you see as the body? Because some people see the bodies differently. There's 4 as a body. So they all have 4 as a body. Does anybody see a body differently than just 4? Dylan?
The 4 and then the 4 on the bottom too.
Okay, he sees the 4 in the middle, but then like the hip area of the invaders. Okay. Or he could see it as like a 6-pack and 2 hip bones, maybe.
And 2 long and 2 straight bones.
Well, we're talking about his body right now, so a 6-pack and 2 hip bones. Tristan, what do you see?
Their eyes are doubling.
Okay, we're not on eyes yet, just the body.
But it's a part of the body.
Okay, not the core body.
It's all blue.
Okay, they're all blue. I do see that. What is different about them? I did ask.
Their legs.
Oh no, I said the same. The same. The legs. What's the same about the legs?
They're all 3 on the side.
All of them have 3. Oh, the little stringy things. Okay, let's. They do all have 3 stringy things on the legs. Let's focus on the blocks themselves. Okay, so what is something that is different? How are they changing? Yes, sir. Their eyes are doubling each time. Is that happening?
I kind of already said that.
They're adding 1 to each side.
They're adding 1 to each side. Okay. Almost looks like they're doubling, but they're just adding 1 to each side. What else is changing?
For like the legs, they're adding 1 leg
To each side? To the hip bone, right? Okay, so they're adding 1 leg to the hip bone on each side every time. I see it. What you got, Tristan?
There's, I already said what
Okay, good. All right, so this is Invader 1, 2, and 3. We needed to write on number 1 what we see different about the growth. How much is it growing each time? How many body parts? Just 1 block each time?
4.
It's growing 4 body parts each time, so we're going to write what's different is adding 4 body parts. And where are those body parts going? 2 of them is going to the legs. 2 is going to the legs, and 2 are going for the eyes. So that's what we're seeing is happening to each invader. Also on number 1, in that grid, they want us to draw the 5th alien and what he would look like. So take a second and draw what you think the 5th alien would look like. Okay, wait for everybody else. Alright, I'm going to draw the 5th guy using some information you've already told me. So I don't remember who, but someone had said that they all have a 6-pack with 2 hip bones. So I'm going to draw first a 6-pack and 2 hip bones. Okay, that's what they all have the same. Well, Invader 1, how many eyes are in each side? 1. Invader 2, how many eyes are on each
2.
side? Invader 3, how many eyes are on each side? 3. So what could we conclude that how many eyes is on each side of Invader 5? 5. So I'm going to draw 5 eyes on each side. Okay, there's the eyes. Now we have the hip bones. Invader 1, how many legs were added to each side? 1. Invader 2, how many legs were added to each side? 2. Invader 3, how many legs were added to each side? 3. So how many legs should I probably add for Invader 5? 5 to each side. We already have the hip bone. 1, 2, 3, 4. So there is what Invader 5 should look like based on looking at the patterns. Okay, well let's go to 2 and put this into a table. So let's sketch a table kind of like my table here. One column is going to be titled Invader Number, and it's representing X. The next one is number of body parts, Y. And we're going to look at Invader 1, 2, 3, 4, and 5. So sketch you a table that looks like mine. For number 2. No, just the table part. Okay, so Invader 1, what total body
12.
parts does he have? 12? Do we agree with 12? You're 12.
12.
Dylan?
Do the legs count?
Yes.
Like
The whole body. Oh, not the little, just blocks. How many blocks? So how many body parts of blocks? 12. Okay, what about Invader 2?
24.
Or 16. Or 16 and 12. I want to say 4. Give me 24.
16 body parts for 2.
Multiply 12 by 2 by accident.
Okay, I hear 16. Invader 3, how many body parts? 20. I hear. Let's skip 4 because we haven't really looked at 4 yet. 5, how many did we have?
Who said 20?
28. 28. So if I didn't have a picture of Invader 4 right here, could I look at my table and a pattern to figure out what 4 would be? Isaac?
Yes.
What pattern do you see?
I see 12, 16. They're counting by 4.
Isaac has the 4. They're counting by
4.
4. Very good. So what would that make you feel like Invader 4 would be?
24.
All right, I hear 24 because they're adding by 4 every time. Check this. We are good. So we used patterns in a table to help look at the body part numbers. Okay. Question 3, 4, and 5 is looking at 3 different people's work and how they saw the invaders, the same invaders. So, are they looking at different invaders? Nope, the same invaders. So, they're all going to have the same total number of body parts, right? That we just looked at. But they saw the invaders broken up into different ways. Is it okay they saw it in different ways? Yes, because we're all different. So we're just going to look and see if their ways work out. Method 1 is kind of how we saw it. We saw a body plus the limbs. What are limbs? Legs and arms is limbs. Well, they're considering their eyeballs limbs, I guess, huh? They're kind of like, look like arms here. All right, so underneath your picture on 3A, kind of draw a table like mine. Write 1, 2, 3, then write limbs plus body, and we're going to fill in some information. So kind of write it like a table like mine. 1, 2, 3, limbs plus body. And this is kind of a method that we looked at just a second ago. So this is going to probably make the most sense to most of us. All right, so looking at the body, which is the purple section, does it change throughout the invaders? Stays the same. Of how many body parts?
8.
8. So every time it's 8? Yes. So could I go ahead and fill in the body of 8 for all of them? Okay, I know all of them is adding 8 body parts just for the body. Would that make it the same for the equation as well? Plus 8? Yeah, I could go ahead and add that in too. Bless you. Okay, the limbs on Invader 1. How many limbs, and what color do they color code limbs here? Green. So how many limbs does Invader 1 have? 4. Does Invader 2 have the same 4 that Invader 1 had?
Yes.
He has the same 4, but what else has been added to it?
4.
For another set, right? So, for our mathematical purposes, it is 8, but I want to write it like 4 plus 4. You'll see why in a second.
Wait, expressions like. Are you using expressions?
Right now.
How's the green ones? Oh, I'm counting
Okay. So it had the original 4, and then another set of 4. Okay, so Invader 3, did it have the original set of 4? Then it had another set of 4, and then it had another set of 4. So how could I write that for Invader 3?
4 plus 4 plus 4.
Very good. 4 plus 4 plus 4. Yes, sir. I'm about to show you. Boys. Okay. Now here's why I expanded that out. When we're looking at expressions and equations, we always have to use our numbers off to the side here. And we have to find it being used. Hold on. We have to find it being used in our expression. So I have a 1, 2, and 3 being used. Where do you see it being used in this math, Tristan?
I think every time 4 is added, it's how much 4s. Every Invader number is another time you have to add 4.
Okay. What you got?
You multiply 4 by the number of or the family number, and then add that by 8.
Okay, he's saying I could have taken 4, multiplied it times the Invader number to get how many limbs. So what's in Invader 1? What's 4 times 1? 4. Did I change this limb answer? No. Okay, well, he had 4 limbs here. What's a 4 times 2?
8.
Does that change is that different than a 4 plus 4?
No.
No. Here, I could have done 4 times 3, which is 12. Is that the same as 4 sets of 3s? Okay, so did we find where this number was being used? Yes. So I could have said 4x here and called all of these x to find my Invader number for any Invader. It says, explain the method of counting the growth. We're going to say the core body of 8 is like an upside down T. We looked at that, right? In the core purple, kind of like an upside down T of 8 of them. Then each member adds 4 more limbs every time. So write that for 3B. Well, right now, all I have is an expression. Why is that an expression? Expressions do not have
The answer.
the answer or equal sign. So right now I have an expression. C asks for an equation. What does an equation need?
Equal
An equal sign. Well, it needs to equal to something. It needs to equal to the total number of body parts. But it doesn't have a total number of body parts. So what did they say they want me to call that? Y. X is the family member number. We already have X in the problem. So how can I write this expression as an equation? 4x plus 8 equals y, or I could write it y equals 4x plus 8. Both of them are correct. Very good. Y equals 4x plus 8, or 4x plus 8 equals y. Okay? That was one person's method. Now we're going to look at a different person's method of looking at the same invader. Okay, so they looked at it differently. That's number 4. Okay, and they have it color-coded here. So we need to write a little chart. And we need to label the chart 1, 2, 3. Then eyes plus legs plus body. So we can fill in and see how this second person looked at the invader family. Okay, we ready to look at it? Your chart's done? Okay, Invader 1. First, let's look at all the invaders and how they color-coded it. They colored the eyes one color. They looked at the body differently. They saw just a six-pack with no hip bone this time. Then they saw a set of legs. Okay, so they saw all those broken up differently, which is okay if we saw it differently. Well, what body section stayed the same throughout this time? The body, and how many parts was in the body every time? 6. So we could go ahead and fill in a +6 every time, because that did not change. Did any other, the eyes or legs, did it stay the same throughout where I can add just one number? No, it changed. So let's look at the eyes first. So the eyes in Invader 1, how many eyes are there? 2 eyes. But I want to use this special number. of a 1, so I don't have to think back on that at the end. So how can I do, we know there's 2 i's. How can I include a 1? 2 times 1, I could do that. Okay. Well, for the second one, I need to include a 2. How many i's does the second one have total? 4. So how could I write this one? 2 times 2. I included that magic number. Now the third invader, how could I write his i's? 3 times 2. Or 2 times 3. So, remember we call this number x. So is the first number or the second number where we plugged in our x? The second. So I'm going to write an x above it just so I know where it's located. So I know for the i's, no matter what invader it is, I need to multiply their i's times what number? 2. So that's why I write 2x in my expression. All right. Now looking at his legs. How many total legs does an invader 1 have? 4. But again, I need to use a 1. What is some multiplications of that has a product of a 4? 4 times 1, what else is 2 times 2? Okay? Well, let's skip and look at Invader 2. How many legs does Invader 2 have? 6. So I need to multiply it times a 2. 3 times 2. So what number, it stayed the same from here to here? 2. So 2 times something, but 2 times 2 doesn't work out here, right? It's 2 times 3. This one was a 2 times 2, right? But I needed it to be a 1. So how can I break up a number of a 2 to have a 1 in it? 1 plus 1, doesn't that equal 2? Yes. Okay, I need to break up this number here to include I know it needs to be a 3, but it needs to have a 2 in it. So how can I do that? 2 plus 3? There we go. 2 plus 1 equals 3. So that's 3 times 2. Does that give me 6 legs? Yes. Okay, this one is 2 times something. What is it? I need that something to total. I need it to total 2 times 4. Because it's 8, right? So I need this. It's got to have a 3 in it, though. 3 plus 1. Okay, so let's look at what stayed the same throughout here. All of them had a times 2? Yeah. Okay. Did in the parentheses all of them what, Tristan? Added by 1. And this number is called x. So this first number would be called x. So I have a 2 times the x plus 1. That one was a little challenging to see, huh? That person was a little extreme. But is he wrong?
No.
He still saw different body parts broken up differently. He's fine. I won't make you write the paragraph of how that's explained, because I think we broke that up pretty extreme, huh?
Yeah.
Okay, but we need an equation. Right now we have an expression. How do I write an equation for that?
Maybe you could do 2x plus, 2, open parentheses, x plus 1, close parentheses, plus 6 equals what?
Equals y. So I need to tag on a equals y because that's what they said in the equation. So it should say y equals 2x plus 2 times x plus 1 plus 6 would be my equation for this one.
It's really not a question about which is why why
Okay. One more problem that I'm looking at today. Is a different method of the same invaders. I kind of ended up liking this method, but I didn't know what they were talking about at first. So I'm looking at method 3 on number 5, and they color coded it kind of crazy when I first looked at it. They made 4 different sections. First, let's take a second to write a table. We're going to write 1, 2, 3, and then we'll call this body parts. So it's a small table. So 1, 2, 3, then body parts. Okay? So I was like, what in the world? They see 4 different sections. Well, I'm going to circle the sections they see. They see 3 yellow. They see 3 purple, 3 green, 3 orange. Kind of made a butterfly. They kind of saw it as a butterfly. Okay, and how many was in each circle? 3. Okay, and then for the second invader, if I made it a butterfly, it still had 4 sections. How many is in each section? 4. Okay. Then the third one, they still saw the butterfly, but how many is in each section this time? 5. Okay. So what they said, remember we have to figure out how to use this number in our problem. So, how many groups? They all have how many groups? 4 groups, huh? They were 4 wings. Okay? So they all have 4 groups of something. 4 times something. This one we know it needs to be 4 times what? 3. But I need to make 3 written as something else using a 1.
2 plus 1.
2 plus 1. Can that work every time? Let me. What did you? What? Will the plus or the multiplication?
The plus 2.
So you're saying 2 plus 1?
Yeah.
What would this one have to be? 3 plus 1. But I didn't even use a 2 though. So can I use a plus? I gotta use a 2, but something's gotta be the same throughout. Can something be the same throughout?
Oh wait, I got it.
The 2, Dylan?
Yeah.
So what are you saying change it to?
2 plus 2. And then 2 plus 3.
Oh, so it's a 2.
And then the next one's 2 plus 3.
And then 2 plus, that's 5. 5.
There's. Yeah,
Did I have something same throughout?
2.
That could work. Or
Couldn't you multiply?
I could have multiplied maybe.
I thought you said you had to keep that one though. You could do
I could do,
3
ooh, I can't multiply, can I?
3 times.
I can't multiply.
3 times
3 times 1, but then it would have to be 3 times 2, that wouldn't work. So I can't multiply. So, where was this number used, my x number used in this problem? The 4 spot, the 2 spot, or the different spot? The different spot. It's always in the different spot. So what is my expression then?
2 plus x.
4, 2 plus x. They wrote it as 4x plus 2. Is that the same thing? Yeah. So I kind of liked, after looking at it, I kind of liked how they did the butterfly method here. I didn't never see it as a butterfly. So again, we won't write how the paragraph, but what would my equation be here?
Oh, y equals 4 times parentheses 2 plus x.
Y equals
No, 2.
4 parentheses x plus 2, or we could have said 2 plus x, however you wanted to say it. So y equals that is my equation. So can expressions be inside of an equation? Yep, we just added an expression inside our equation. The one that changes throughout. Okay, so we'll finish this up tomorrow. Thanks for listening. Have a great day. Like, subscribe, hit the notification bell, and happy birthday, Kaden. Yay!